We're talking again about the distance from a point to a line. So this is coming back to something that we already talked about last class or 2 classes ago. And we're going to be applying it to situations within a circle. So here we go. Scenario. Alberta is Canada's main oil-producing province, but there are significant oil fields elsewhere in Canada. One of the latest to be exploited is in Hibernia, which is under the Atlantic Ocean, on the Grand Banks. The Hibernia drilling platform is located 315 kilometers east-southeast of St. John's, Newfoundland. Oil is transported to shore from the offshore oil platform by oil tankers. The platform must also receive regular visits from supply ships that come from different places along the coast. Find the shortest distance between the coast and the platform. Finding the shortest distance is important to reduce costs. So here we go. A radar operator on an oil platform is monitoring the positions and courses of ships on a radar screen. In the diagram, the innermost ring represents a distance of 5 kilometers from the platform. So the platform is at P, and each ring represents 5 kilometers from the platform, okay? Each successive ring represents an additional 5 kilometers. What is the scale of the diagram? So in order to determine the scale of the diagram, you'd have to get out a ruler and measure the distance between each ring. And you'll find out that the rings are separated by 1 centimeter. And so if we have a span of 1 centimeter from ring to ring, and we know that each ring represents 5 kilometers, how would we record our scale? So we'd have 1 centimeter.
4 centimeters.
Is 5 kilometers. Okay, so this is a ratio. This is a good way to record your scale. The ratio is, on the map, you go 1 centimeters, and it really means 5 kilometers. Okay, that's our scale. So here we go. We're going to use our scale. We're going to use our diagram. We're going to use our brains and estimate the closest distance in kilometers that each of the following ships will come to the platform. So we're going to get each of these ships, and we're going to find out which, we're going to be given what direction that they're going. We're going to draw that line, and then we're going to determine how close they come to the platform. So again, you'll need your ruler out, a straight edge of some sort at any rate. And the first thing that we have is ship A. So find ship A. Ship A is going to travel on a course of 180 degrees. You have your direction, your whatever this thing is called, I'm drawing a blank. But anyway, it tells you which direction the boats are going. 0 degrees is north, okay? 90 degrees is east, 180 degrees is due south. So this thing is on a course of 180 degrees. So which direction is it heading? South, straight south. So from A, ship A, you're going to draw a line straight south. Okay? That's the direction that it's heading. Well, approximately, what is the closest that it will ever come to the platform? So count your rings. Each ring is 5 kilometers. It's 3 rings, so we're looking at about 15 kilometers. Little squiggly line means about, approximately. All right, ship B on a course of 270 degrees. So we look at our little map. That means ship B is heading due west. So we go ahead and draw that straight line. Again, it's an estimate. And how close would you say this ship will get to the platform at its closest?
9 kilometers.
Maybe 9 kilometers. 8 kilometers, maybe 10 kilometers. Okay, it's approximation. And go ahead and do ship C on your own. Use your ship C traveling at a course of 120 degrees. And the closest it comes is about 5 kilometers. In step 3, so now you have 3 lines drawn. You have traced the direction of ship A, ship B, and ship C. Now in step 3, we're going to choose one of those ships. Doesn't matter which one you choose. And determine where it is closest to the platform P. So where along its line that we drew, its ray, is it closest to the platform? And then draw a line segment from the platform to that point. So pick that point on the line where it is closest to the platform, and then draw a line from the platform to that point. I've done it from ship B. Doesn't matter what ship you did it from. You could do it from any of the ships. But if we do it from point B, what do you notice between the line that I drew and the path of ship B? How do they meet? They meet at a right angle. Go ahead and do that for the other ships, if you haven't already. What does this investigation confirm for us? Well, the answer for 3, at about what angle does this new line segment meet the line that represents the course of the ship? 90 degrees, or a right angle, or perpendicular. Okay, all of those words would describe how these two lines interact. And so what have we actually figured out here? That the shortest distance between a point and a line is always along the line that meets it at a right angle. The shortest distance between a point and a line, between point P and any of our lines, is along the line that meets our previous line, our initial line, at a right angle. Okay, so we're talking about slopes, and we're talking about distances. All right, example 1 says determine the shortest distance from the origin to the line y equals 2x minus 10. And we want that as an exact solution and then as an approximate solution. So as an exact solution means we're going to leave our answer as a radical if needed because we're using the distance formula here. We're getting the shortest distance, so we're going to be applying the distance formula. And let's kind of think through what we need. So we're getting, the point of the question is to get the distance, right? Distance from O, which is the origin, to, and we can call the point where they intersect A. You guys have a nice little diagram there. Maybe we could think about what's it going to look like if we're going from O to A and we have the shortest distance possible. What is that line going to look like? Our new line. From O to A. Where's A going to be? Is A going to be down here? It's going to be here? Ish? Yeah. Okay, we really want to meet this line at a right angle. Okay, that's pretty close. Remove that dot, put our A there. Okay. So that's what we're looking for. We're looking for the distance between O and A. What do we need in order to get the distance, in order to use the distance formula? We need 2 points. Do we have any of the points yet?
Well, you have like the origin.
We have the origin.
Like 0, 0.
0, 0. Okay, well that's easy. And the distance formula is really easy to use when you're starting with the origin. So nice of them to do that for us. Here's my distance formula, just because I know we're going to need it. You said that in order to do that, I need 2 points. So I have point O. You're saying I need to find point A? Okay. What do I need to do in order to find point A? Algebraically. How do I find point A? What's interesting about point A? Point A is where?
It's perpendicular to the other line.
Okay, so one line is perpendicular to the other line. In order to find point A, I need to find the point of intersection. Right? Point of intersection, well, in order to find the point of intersection using substitution or elimination, I need 2 equations. So I need equations for both lines. Well, in order to develop an equation for either line, what do I need to know about those lines? What's one of the key characteristics of a line that we like to know about in order to use that line or think about that line? Going through it piece by piece. Okay, we need equations for both lines, which means we need slope. Okay? If we find the slope of our original blue line here, which we can get because they gave us the equation nicely in y equals mx plus b, what do we know about the slope of the pink line? It's going to be the opposite reciprocal, right? It's going to be perpendicular, okay? So here we go. We're going to go for slopes. I'm going to call us M1. I'll do in blue. Since the equation of that line is y equals 2x minus 10, what is the slope? 2 over 1, or just 2, right? How do we know that? Well, the equation is in slope y-intercept form. It literally just tells you exactly what the slope is. It's the number in front of the x. Okay, y equals mx plus b. Okay, so if m1 is 2, we're looking for the slope that's perpendicular for our second line. What's that going to be? Okay, make sure you're getting opposite and reciprocal. It's got 2 words. That means 2 things have to happen to it. Good. We've got our slopes. Now, how do we get the equation of a line? Well, we have point slope formula. So over here, on our blue line, y minus y1 equals mx minus x1. Do we have a point that it goes through? Actually, we already have the equation of the line, so there's really no use in doing what I just did. They already tell us it's y equals 2x minus 10. Okay, we have the slope and we have the y-intercept. So now we go over to our pink line. What do we know about that line?
It's slope
We know its slope, and we know one of the points. What point do we know? Yeah, 0, 0. The origin is at 0, 0. So we've got y minus 0 equals negative 1/2 x. I'll use the brackets, sorry. In brackets, x minus 0. And now it's just basic algebra to distribute on the right side, and on the left side we have y minus 0, which is y. On the right side we have negative 1/2 x. Anything else on the right? Nope. Anything times 0 is 0. So now we have two equations and two lines. Call this line 1. Call this line 2. Equations for both lines. Now what? Find the point of intersection. What strategies do you have for that? What would you like to use? Substitution. Okay, we know y is this, and we know y is this. Okay, what does that tell us? It tells us that 2x minus 10 is equal to negative 1/2 x. Okay, I'm going to add half of an x to my left side. Okay, another way to do this is if I don't like this fraction, I could multiply everything in the equation by 2, and that would eliminate the fraction. Which way do you prefer? Get rid of the fraction. Okay, so all I'm going to do is make sure I multiply every term by 2. So on the left I have 4x minus 20, and on the right I have negative x. Now we can add x to both sides and add 20 to both sides. So I've got 5x on the left and 20 on the right. Divide both sides by 5. X equals 4. Are we done? Nope. Now we're going to sub into either equation in order to determine what y is. I'm going to use equation 2. Y equals negative 1/2 times x, which I know is 4. Negative half times 4. Well, I cut 4 in half, so it's 2, and I have a negative sign. So it's negative. Okay, that tells us point A. I can add that to my diagram. It's 4, negative 2. Are we done? Well, we found the point of intersection. Now we just need the distance from the origin to A. Now, because the origin is at 0, 0, we really just need the Pythagorean theorem by itself, because we're not going to have, the change in y and the change in x are really easy. The change in y is 2, and the change in x is 4. And if you want, you could put a negative 2 there. Okay? So it's really easy. But if you want to see the whole distance formula applied, we can do that too. So we're going to get the distance is equal to the change in our x's squared plus the change in our y's squared, and we're going to square root that. So again, we can do this kind of in our heads. The change in x ends up being 4 minus 0, which is 4 squared. And the change in y ends up being negative 2 minus 0. So you have negative 2 squared. Then you can, if you're getting good at this, you can do it all in one step, but I'll just write down each step. And the question asks for it as a exact value. So this is the answer to A. The distance from OA, you could even say OA equals radical 20. Okay, the square root of 20. That is the answer in exact form. If you need an estimation or an approximate answer to the nearest tenth, what should you do? Put it in your calculator. Square root of 20. And then we would get OA is approximately, okay, so you need to put the equal sign, a little dot above it, 4.5. And it's not measured in any particular units, so 4.5 is good enough. And we're done. Okay, again, we've done it several times now. Make a list of things that you need and think about, what do I need in order to find that? What do I need in order to find that? What do I need in order to find that? You're usually going to start with slope. Then you're going to be looking for equations, a point of intersection, and then you can do distance. Okay?
You want us to find like the answer answer or just wait what we need to?
As long as you're generating your list of things that you need to do. So you look to the question, it says find the distance. So that's what you're going to be doing last. Find distance, and we can call it PQ. Find distance PQ. In order to find the distance, you need 2 points. In order to find, in order to find 2 points, one of those points you already have, it's P. The other point is going to be Q. Well, what is Q? It's the point of intersection. How do you find a point of intersection? You need 2 equations. You already have one of those equations. How do you get the equation of PQ without having Q? You need the slope. Okay, what do we know about the slope of PQ? So it's perpendicular to the given line. And now go ahead and look back at the equation that they give you for the given line. Can you get the slope out of that real easily? Yeah, we need to convert it, right? So we can't get the slope from that because it's in standard form. So a couple of extra steps here, but much the same problem. Okay, and now we just work up from the beginning. So we have this equation that's given. Equation 1 is x plus y minus 5 equals 0. How do I get that in y equals mx plus b?
You have to bring x and 5 to the other side.
How do I move stuff in an algebraic equation? Subtract x and add 5. So I've got y by itself on the left, and then I've subtracted x and I've added 5. So what is the slope of the first line?
0. 0.
Yeah, it's -1 or 1.
-1. Okay? If it were 0, this whole term would disappear. There wouldn't be any x's. Okay? There's an invisible 1 in front of the x. There's -1 x's, so our slope is -1. The slope perpendicular to that then, the slope of our second line, is what? +1. Opposite reciprocal. -1 over 1. Flip the fraction, you still get 1 over 1. Take away the negative, you get positive. So we're looking at +1. So we've converted to y equals mx plus b. We've gotten the perpendicular slope. Now we're looking to put PQ into point slope form. We have a point P, and now we have the slope. So here we go. Y minus y1 equals mx minus x1. Plug in what we know. In the last example, the point was the origin, 0, 0. Made it really easy. In this one, it's not. We have a y coordinate of 3. We have a slope of 1. We have x minus -1. I'm going to leave the left side for now as x minus 3. On the right side, distributing 1 to something is really easy. Inside this bracket, x minus -1 is actually x plus 1. And if I have one of those groups, then it just stays x plus 1. At this point, we can add 3 to both sides. And we end up with a second equation, y equals x plus 4. So now we know that the two lines are y equals -x plus 5 and y equals x plus 4. We have two equations. Our next step is to find Q, the point of intersection. How do I do that? Sure. If I know y equals this and y equals this, and at the point of intersection Q, that's where x and y in each equation have the exact same solution, then all I need to do is set x plus 4 equal to negative x plus 5. Go ahead and use your algebra skills to solve for x. Once you've solved for x, you need to solve for y. Which gives us the coordinates for point Q. Which means that we have 2 points, which means that we can apply our distance formula. We have the distance PQ is going to be equal to the sum of the squares of the horizontal distance traveled. We can go from P to Q, so I'll go 0.5 minus -1 in the first bracket. And in the second bracket, we've got 3 minus 4.5. That means in the first bracket, we have 1.5 squared. In the second bracket, we have negative 1.5 squared. 15 squared is 225. So 1.5 squared is 2.25. This is 2.25 plus 2.25, which gives us the square root of 4.5. And we're asked to get this to the nearest tenth. It's 2.1. And we put a dot above it because it's an approximation. 2.1 units. PQ. All right, really helpful. Make this chart, okay? What's your goal? Question says, find the distance. Okay, what do you need for distance? You need 2 points. How do you find 2 points? You need point of intersection. Well, you don't have the point of intersection, that's Q. So in order to do that, you go back to what you learned in previous lessons and units. You need 2 equations. In order to get 2 equations, you need the slope of both equations. In order to find the slope of your second line, it's the opposite reciprocal of the slope of your first line. But in order to get the slope of your first line, we needed to convert into y equals mx plus b. Okay, step by step. Think it through, then complete it, and complete it step by step.